थोड़ा सा उनको पूछ लेंगे।
एग्जाम कब है?
एग्जाम अभी वेनसडे को है, फर्स्ट
थर्ड
3rd
थर्ड को है, थर्ड को।
दिसंबर, वेनसडे।
231 30 है पहले।
पहले 231 है मोबाइल कंप्यूटिंग, फिर 9th को 230 है।
ओके।
ऐसे कुछ शॉर्ट नोट्स किसी ने बनाए हैं क्या प्रीवियस ईयर्स?
Good morning, sir.
Sir, how are you, sir?
Fine. What about you?
All good, sir. All good.
All good, sir.
Fine. Okay. अच्छा, so last class we have discussed some application of mobile computing. We have already discussed the smartwatch, music, video, e-books, mobile check, mobile wallet. These are the easy. Mobile commerce. The important is the caching techniques. That is, you know that that is the most frequently used data are cached in the mobile app in client machine, and so that if any request come, it fetch the data immediately, and it is called your cache miss. That if the data is not found in the app, when the mobile app does not find any data in the local cache, it is called the cache miss, and that mobile app has to go back to the server to get the required data. And the most important thing is we need to use appropriate cache invalidation mechanism to ensure that the mobile clients gets the accurate data. That means it must be synchronized so that it will get the client accurate data. So there are four invalidation method as we discussed: stateless asynchronous, stateless synchronous, stateful asynchronous, and stateful synchronous. That is stateless asynchronous means in which a broadcast message invalidate all the cache object of all clients of the server. Suppose the client server, the data server is updated, so the data which is already present in the client cache is invalid. So a broadcast message invalidate all the cache object of the client of the server. Stateless synchronous, in which the server broadcasts the cache invalidation method when the data is changed or modified. Suppose some data is modified in the server side, so the server broadcasts the cache invalidation method. Stateful asynchronous, where the server broadcasts the cache invalidation message only for the specific client who are impacted. It is not meant for the all the clients, only those clients who are impacted. So only it broadcast the that invalidation message only those client only. The server does not keep track of the client data. And stateful synchronous means where the server keep the track of the client data and broadcast the cache invalidation message to the specific client when the data is changed. Okay, so I have already discussed this. WLAN, I think discussed. So I think I have discussed in the WLAN last class. Zigbee and Wi-Fi. Wi-Fi. We know that these are both the wireless communication technology, but they serve different purpose and are optimized for different type of application. You may get a question a short note on Zigbee, or difference between Zigbee and Wi-Fi, or comparison between Zigbee and Wi-Fi. Uh, the purpose of Zigbee is designed so for low power, low data rate application, particularly in the content of the Internet of Thing. Basically, it is low power. That is the devices which using GB. It is low power and low data rate application. That is the data rate here is low. It focus on enabling device to communicate wirelessly over short distance while consuming minimal energy. So in some area, that is the energy may be a constraint, the power may be a constraint. So we use Zigbee. We prefer Zigbee to Wi-Fi, where the energy, that is your uh, power, is a concern, is an issue. Uh, and that is there is no constraint in data speed, because the Zigbee devices basically low data rate. That is their the data rates are low or slow as compared to Wi-Fi. So it range Zigbee relatively short, typically around 10 to 100 meters, making it suitable for local area network and home automation within a confined space. Similarly, Zigbee devices are designed to be energy efficient, as we discussed, allowing them to operate the battery power for extended period or even with energy harvesting method. So this is using low power. Because as it is moving, there is no constant supply of power. Zigbee supports mesh networking, where devices can communicate directly to each other and relay message for device uh, out of direct range. This enhances network coverage and reliability. Zigbee is a mesh topology. You please recall, the mesh topology means there is a dedicated path between uh, every two nodes in that network. So data rate offered by Zigbee is slower or lower as compared to Wi-Fi, which makes it suitable for application where transmitting small amount of data over time is more important than high-speed data transfer. So where the small amount of data over time is more important, and where is the energy constant. So at that scenario, we prefer Zigbee. The application of Zigbee is commonly smart lighting, thermostat, door locks, and industrial monitoring and control of the small geographical area. Zigbee operates in 2.4 gigahertz frequency band, which is shared with other wireless technology like Wi-Fi and Bluetooth. This can potentially lead to interface in crowded frequency environment, whereas Wi-Fi also a wireless networking technology that allow device such as computer, laptops, mobile devices, and other equipment. Basically, we are using Wi-Fi nowadays. You know that mobile device we can connect computers, any mobile devices, our smartphones, or printer, camera, your speaker with the Wi-Fi. Wi-Fi is designed to provide high-speed wireless internet access over relatively short or medium distance. The distance also same, but it is the speed is higher as compared to Zigbee. It offers a broad coverage of device needing fast data transfer rate. Wi-Fi has a range of around 10 to 100 meters, similar to Zigbee, but it focuses on providing high data transfer rate for internet related activity. So the speed is higher as compared to Zigbee. Data rate supported are higher, making it suitable for application like internet browsing, video streaming, online gaming, and data intensive tasks. And Wi-Fi devices generally consume more power than Zigbee device. So we already know Wi-Fi devices consume more power than Zigbee devices. Zigbee are low power devices which can affect battery life in portable devices. Although the Wi-Fi data rate in Wi-Fi is higher, but it consumes more power as compared to Zigbee devices. Wi-Fi use a wide range of application, including home and business networking, public hotspot, smart home, mobile devices, and also operate in 2.4 gigahertz and 5 gigahertz frequency bands, which are widely used for various wireless technology. This can lead to potential interface, especially in crowded urban environment. Basically, in a Zigbee, the choice between Zigbee and Wi-Fi depend upon your specific requirement of the application, considering factors such as power consumption or data rate and range. And if you need data rate, you should be high. That is, you need quick response, or you need your data rate should be high. You use Wi-Fi devices. Otherwise, suppose your data rate is not a concern, but power is a concern. Power is a constant there, so you use Zigbee instead. Mobility, portability, replication, and clustering. Mobile devices are used for various use in case of daily life. We use mobile device to chat with our friends. So these are the different application or use of mobile phones. Play games, navigate through maps. So modern day smartphone provide machine learning or artificial intelligence enabled features such as vision, image recognition. You know that face recognition system, augmented reality, many other features. Customer, enterprises, business all use mobile apps to deliver information, services, and to share resources. Okay, so these are what are the challenge in mobile data management? What is data management? You see, mobile devices manage the data required for its services and apps locally as well as on a remote secure cloud database. We know that some data is cached in the mobile apps locally, and some data which is not available in the cache, it must be brought from the uh, remote machine or server. The mobile data include the contact list, photos, media files, conversations, document, game, data, and so these are known as the mobile data. Your contact list, any photos, any media files, any game. So mobile device store these file in local database and also regularly synchronize the file with the remote database. Otherwise, you will get inconsistent data. The data must be synchronized with the local devices with the global devices or your server. A mobile app might use the data that is distributed across the various database. For instance, a gaming mobile app might use the authentication service from the enterprise activity directory, and it might use the cloud database to process the game details such as game labels, game point, and given users. Hence, the mobile device has to process the queries of distributed database. We have depicted a mobile computing system in that use distributed services and database across the cloud platform. So, some challenges nowadays. What are the data challenges in mobile data management? Data synchronization. So we know that data synchronization is important. Otherwise, you will get inconsistent data. That is, if the data are present in a local cache and the data is already updated in the server, it must be synchronized. So the data has to be stored in local database as well as on the remote database. We need to design the efficient data synchronization process or data synchronization algorithm to synchronize the local data with the remote database on the cloud. Okay. Otherwise, if data is not updated, if data is not synchronized, you will get the wrong data. So data synchronization process, we need a appropriate or efficient data synchronization process. Transaction management. At the mobile app work with distributed database, maintaining the data integrity. We know that in a process management, you may know the acid property, atomicity, consistency, integrity, and durability. We know that there are four property of a process management, a transaction management. So all the transaction must be atomicity. That is, if it is changed in one machine, it change to all machine. Otherwise, not change at all. So data integrity should be maintained. Data consistency. Data must be consistent. So strict consistency and correlation of data across the database become a challenge. So to maintain this property of the transaction, also it is a challenge. You should need the proper or efficient process or algorithm to handle the transaction process. That is, you know that if there is a remote system at a time, more than one or more than 10 or more than 1,000 user may use a server. So there may be maybe any problem comes. So to handle that, the transaction management, the accurate or efficient transaction management process must be there. So it is also a challenge in data management. Data processing. We know that some data are processed in the local machine and some data is processed in the uh, remote machine or server sites. So this should be identified. This is also a challenge. Network connectivity. Due to dynamic nature of the mobile network, the mobile apps need to handle the data management and unpredicated network condition. One of the popular approach to use offline fast approach where the data is stored locally during low network scenario and it will be synchronized when the remote database when the network stabilized. So if the data is present in the local cache and suppose there is the network is low, so suppose there is no network or very low, so it is difficult to synchronize the data with the server. Besides that, the data security. The data at rest and data as a transit has to be secured through encryption, transport level security, and other mechanism. So proper mechanism, security mechanism should be employed. Managing location. Dependency mobile app need to handle the queries that are location dependent and need to manage other dependency. So location also another problem. Data security also another challenge. Resource management. As the mobile device has limited compute, storage and battery capacity, the mobile has to manage the data within these constraints. So let us discuss two important uh, protocol in transport layer, UDP and TCP. You may heard about UDP and TCP uh, as you compare them. Uh, User datagram protocol and TCP transaction control protocol. So UDP is connection less transport layer protocol. UDP is used in transport layer, but it connection less. You know that there are two type of protocol. One is connection less, another is connection oriented. Connection oriented means that first the connection is take place, then data will be sent. And connection less means data will be first sent and then the connection will be established. Okay. Suppose you are sending a letter to your friend via suppose post office. Okay, so you first send and then connection establish. And suppose when you want to talk your friend, so first the connection will be established, then you are able to talk. So this is connection oriented. So UDP is used for fast transmission of data across two computers. It is unreliable as it does not wait for acknowledgement from the receiver. So it is if data is uh, received, so it is, does not wait for the acknowledgement of the receiver. Okay, so UDP has solved the bandwidth as it does not depend on the acknowledgement. So it saves the bandwidth. If the acknowledgement is not there, so the data will be sent faster. Each of the UDP segment are handled individually and use independent path to reach the destination. So as you know, the total message is divided into small parts. In case of UDP, it is termed as segments, but in case of TCP, it is a term as packet. So UDP segment are handled individually and use independent path to reach the destination. So they are individually path and independent path. UDP is faster as it start transmitting the data packet or datagram. Sometimes the data packets are known as datagram or segments to the target computer without waiting for the handshake or acknowledgement. So the data once it is start transmitting data before the connections take place, and also it is not wait for the acknowledgement. So it is faster as compared to the TCP. This process make the UDP faster but unreliable. Why unreliable we will discuss, but this process make the UDP faster. The reason is that it does not need the acknowledgement, so bandwidth will be saved. You see here. So the client machine make a request or the sender send the data, then response, then response, then response. It did not wait for the acknowledgement. There is no acknowledgement. So the bandwidth will be saved and data will be faster. So the requester send the request and sender send the response data continuously. As is missed datagram are not retransmitted, the requester has to devise method to handle the data loss and duplicate the data. So as the missed datagram are not retransmitted. So this is not reliable. Okay, so in the previous slide it was written that it is not reliable because if any datagram or any data packet are missed, sir, it is not retransmitted because no acknowledgement is there. So the requester has to devise method to handle the data loss or duplicate data. Okay, so any data duplicate data, the requester has to devise any method to recognize them. So the UDP packet, it's 8 byte long. Source port provides detail of source port 16-bit field. Destination port also 16-bit field. Length provide length of the UDP in 16-bit field. Checksum means your correction, data correction or data, any error correction and detection. That is checksum method. There is a use case, the time sensitive applications such as video streaming app, video broadcasting, audio streaming app, view IP, live conference, screen sharing application and other rely on UDP are the minor data loss is acceptable in such scenario. So the minor data loss is it will acceptable. Suppose the view IP, live conference, high speed, low latency application such as online gaming application use UDP. Low latency and high speed. You know that UDP is high speed as compared to TCP. But as compared to TCP, TCP is a connection oriented, full duplex data transmission protocol that provides assured delivery. It is a connection oriented, but the UDP was connection less protocol. It is full duplex. You know that there are simplex, half duplex. Simplex means only one side data will come. Suppose your TV, that you cannot send data from TV to the studio. It is simplex. Half duplex means one-sided communication, like your walkie-talkies. Okay, but your phone is duplex, full duplex. So as TCP is connection oriented, the connection between the sender and receiver has to be established fast, and then the data transmission takes place. TCP break down the message into various packet and send them to the destination. So as you know, also like your UDP, UDP also break the data to smaller part. It is known as datagrams, but your TCP it is termed as packets. TCP ensures the correct ordering of the data and identified each machine on the network with a unique IP address. It is correct ordering. ensure the correct ordering data. TCP guaranteed the delivery of the packet in the open system interconnection OSI model. TCP covers the whole layer, layer 4 transport layer and layer 5 procession layer. You know that there is in a data networking work of TCP. TCP segregate the data into various packets and provide a sequence number to the packet. So it breaks down the data into packets, and most importantly, it provides a sequence number to each packet. TCP transmit these packets to the destination. At the destination side, the packet are reassembled based upon the sequence number, because already the sequence number is given, so there is no problem in the destination sides to reassemble it. Uh, Reassemble on the sequence number and transmit it further. TCP acknowledge the arrived packet. So it is acknowledged, but in UDP there is no acknowledgement. TCP handles retransmission of the lost packet. So if it did not get, or if does not get any acknowledgement in specified time, it retransmit the data again. So TCP handle retransmission of the lost packet, drop packet or grab packet to provide error-free transmission. There are some feature of TCP. So as you know, there is a segment number, sequence number. All the transmitted or received segment are tracked by TCP using segment numbers. Flow control. The data transfer rate of the sender is controlled by flow control. The receiver using slide window to specify the data transfer for the reliable delivery. Flow control means suppose the data which are sent from a sender is a high rate. Suppose it is you have a good machine, you have a powerful processor, so you send the data in high rate. For suppose the destination machine is the traditional one, so it may not receive the data at the same rate as it is sent. So this problem is known as the flow control, flow control, and to overcome this problem, we have some method is used, which is known as sliding window is one of them. Error control. Each of the transfer segment are checked for error to ensure reliable delivery. Duplicate segment, lost segment, or out of order segment are detected using error control. Suppose some segment is duplicated, it is received twice, and suppose some segment is lost, some packet is lost during the transmission, during the way, so it is also detected. Congestion control. TCP consider the network congestion during routing. TCP eliminate the network congestion using congestion avoidance algorithm such as slow start, timeout, timeout react, additive increase, multiplicative decrease, and such. So this is also congestion control. If there is any congestion in a traffic or in the way, so it use different algorithm to avoid this congestion control. So like your UDP packet, TCP packet also a structure which is different from the UDP. Source port address provide the address of the source port data, send the data. So must contain the source address. Similarly, the destination port address provide the address of the destination port. So it contains that packet also contain the source address as well as destination address. Sequence number specify the sequence of the data byte for a specific session. So as you discussed, in the packet contain the sequence number. Acknowledgement number specify the next sequence number by the receiver. For instance, when the receiver receives a data with sequence number A, then the receiver responds with A plus 1 is the acknowledgement number. So there will be acknowledgement if the data packet is received, the acknowledgement received by the sender from the receiver. So this type of UARG, acknowledgement, push, RST, STN, EN. So these are 6 control flag. This control flags, these are either it is 0 or 1. The control the connection on data transmission. And window size specify the data size that the receiver can accept. It is use and flow control. Checksum is the mandatory field for TCP and used for the error checking and TCP header, TCP payload and the PCP pseudo header. So checksum is also used for in error detection process. Urgent pointer indicate the last urgent data byte. So we have a small introduction to XML. As you know, XML is a markup languages. That is, you have used some tags and attribute for the presenting data. Like your HTML, you remember HTML, which contains some tags, and the tags have some properties known as attribute. The tag define the high-level elementary entity, and attributes define the property of the entity. There are multiple XML-based standards that popular for data exchange and data transmission. XML is a platform language independent structure, so it is very popular nowadays because data exchange and data transmission from XML is easy and supported by many platforms. So XML format is used in variety of scenario. XML help us to manage the data in structure way using well-defined tags and attribute. Sometimes we use our user-defined tags. You can store data in your XML format, and which you can access the other software or other uh, uh, platform. XML is also used to share the data across two systems using standard format. Server can push the data to the mobile client using XML data format. We can also present the object relationship and hierarchy in XML format. So XML can be used as a database where we manage the information, and XML can also be used to specify the commands, define the page layout, specify the constraint, enforce the rule, establish the relationship between the entity. And this is a small introduction. That is, you can use any constraint, you can use any validate XML, and you can use any XML. So XML is used for the you can add the any custom tag, any user defined tag, and custom attribute and element as per the XML. Okay, so this is RMC. So okay, so this is about your mobile computing, and uh, we have discussed some important question on numerical part of the two MCS 230. Will you discuss that? Some numerical parts. Are you there?
Yes, sir.
Yes, sir, we should, sir.
Okay, okay, okay. Please. Please recall. We have discussed DFT, discrete Fourier transform. Basically, which used to transform a image which in a spatial domain to the frequency domain, and also IDFT, uh, inverse DFT. That is, if we convert the an image to the in spatial domain to the frequency domain, it is easy to manipulate. It is easy to store, and after manipulate or after applying some process, we can convert the frequency domain picture to the spatial domain using IDFT. And you see, basically the transformation is required. The DFT converts the finite sequence of pixel values into the set of frequencies, and it is a frequency components. So we have already discussed. We have some application of image processing. So inverse discrete Fourier. Once the modification take place, processing take place, you change that frequency domain to its original domain, that is the spatial domain. So using IDFT. Uh, so this is the working, remove noise, sharpening, reconstruction, we have already discussed. And this is cosine also we have discussed. Uh, Let us discuss some important questions. Uh, Given a grayscale image with aspect ratio 6.6 to 2 and a pixel resolution of uh, 4,80,000 pixel, calculate the following dimension of image, size of image. Have you seen this question? ये क्वेश्चन है तुम्हारा प्रीवियस ईयर में.
सर ये आया हुआ है, ऐसा आता है सर.
इस टाइप का आता है. You see here. If the aspect ratio is at 6 to 2, it is same as 3 to 1. So if the height is, you see, if the height is the h and the width is w, so we know that w is 3h. That is 3 times later. That is 3 to 1. So that is w is equal to 3 into h. Because aspect ratio means width is to height. That is known as aspect ratio. And the total pixel resolution of the product of width is height is equal to w into h. Okay, that is equal to 3h square, because w is here equal to 3h. And h square is equal to this, and h is found 400 pixel. That is height is found to 400 pixel, and width is 3 times from the height. It is 1200 pixel. So this is your what is the dimension? This is the dimension is 400 into 1200 pixel. So dimension of the picture must be 400 into 1200 pixel. And the second question with the added, you see, size of the image. So total pixel into byte per pixel. Basically, we take here 8 by 8 bits, because the standard grayscale image use 8 bits. Okay, sometimes it may come in question. The standard grayscale of the 8 bit, how it is the image size, if it is the image uses 16 bits. So you have to multiply with 16 bit. So total pixel plus bytes per pixel. This is important. Bytes. If it is 16 bits given, you have to multiply with 2, because 16 bit is 2 byte. So size is equal to total pixel into bytes per pixel. 4,08,000 pixels into 1, because it is 8 byte size. So 1 byte is there. So the size is this. And the conclusion is the dimension of the image are 1200 pixel by 400 pixel, and the size is 4,08,000 bytes, or this is kilobyte. You have to divide that. That is, it will give 75. So So this question also there. This is another important question you will get. For a sample mobile phone with a height of with resolution 1080x1920 pixel and the diagonal size is 5 inch. That is your screen is diagonal size is 5 inch. Calculate pixel density in pixel per inch. PPI. Calculate pixel density in pixel per inch. Are you getting the question?
Yes,
There's a
sir.
mobile phone. The pixel is given that, and diagonal size is also given. Okay. Diagonal size of the your screen is
Only
given.
diagonal size ही देते हैं सर अगर वो नहीं भी लिखा है we have to consider diagonal size.
Diagonal size. Okay, so this is your you see we have to two step here. First find the diagonal resolution of pixel. Determine the screen diagonal resolution in pixel using uh, Pythagoras theorem. That is you know that is nothing but that is your uh, width square height square d pixels you see. So first using your Pythagoras, you know that your this is Pythagoras theorem. So diagonal pixel is if it is height and width is given, and you got w square plus h square because it is the hypothesis. So uh, d pixel is equal to approximately near equal to 2202.91 pixel. So once you get the d pixel, that is your diagonal pixel. So diagonal pixel is near equal to 2202 or 220.91. So then we have to find the pixel density PPI per inch. It is not actually difficult, but you have to remember this formula. Now divide the diagonal resolution in pixel by the physical diagonal size in inch. Sometimes it is given 5 inch, sometimes given is 10 inch. So to find the pixel density in pixel per inch equal to PPI is equal to d pixel by d. So 2202.91 by 5.0. So it is near equal to 4 PPI equal to 440.58. अच्छा, I have a question from this city. ठीक है सर खत्म कर देते. You may get this question. Compute the discrete cosine transform DCT matrix of order 2. How to compute the discrete cosine transform DCT matrix for order 2? Sometime I got this question from a previous one. How to compute the DCT matrix order 2? So you know that the discrete cosine transform has several variants, and but DCT2 is being for most common DCT type 2, and the formula provided here is you see CKN, that is the DCT matrix. Following formula CKN is equal to alpha k cos pi 2n plus 1 whole into k 2n plus 1 by 2n. So what is the order n? Capital N is the order of the matrix. Here is 2. n is the row index, that is 0 to n minus 1. So as it is order 2, so it is 0 1. K is the column index. Similarly, it is 0 to n minus 1. As n is 2 here, k is equal to 0 1. But alpha k is a normalization value. It has a value. You have to remember that. Alpha 0 is 1 by n. Alpha 0 is 1 by n. Okay, always remember that alpha 0 is 1 by n. And if alpha k is 2 root over of, sorry, alpha 0 is 1 by root over n. Alpha k is equal to 2 by n root over. Suppose alpha, if k is 1, k is 2, k is 3, any value k greater than 0. Are you getting? What is alpha 0 and alpha, the other value of alpha? You see, in the order 2, there in formula we have alpha k. So what are the alpha k? Now alpha k is a normalization factor. Its value depend upon the n. Alpha 0, if k is equal to 0, its value is 1 by root over n. But if the value k is greater than 0, suppose 1, 2, 3, 4, whatever may be, its value is 2 by n to root over. Are you getting so far?
So for all k greater than 1,
Greater than
it's
0.
always under root 2 by n.
2 by n. Greater than 0, not 1.
Greater than 0, yeah. Okay.
Greater than 0, yes. So in this way, you can get the alpha k values. Okay, alpha k value मिल गया. अभी क्या we have to find only cos part, cos and the bracketed part. Okay. So you see here in the next slide, you see. So we already calculate this. First, calculate the normalized factor alpha 0 and alpha 1. As n is equal to 2, alpha 0 is equal to 1 by root 2, 1 by root n. What is alpha 1? Alpha 1 is equal to
2 by 2.
2 by 2 root over 1. Is it okay? Something.
Yes, sir.
Okay. Then come to the cos part. Calculate the each element of the 2 cross 2 matrix. Because it is order n, so in the question it asks order n. So basically it is first order n. First C00. Let's go to the again. You see, putting k is equal to 0, n equal to 0. You see here ckn. We have first find C00. Putting k is equal to 0, n equal to 0. You see, k is equal to 0, n equal to 0. Then C00 equal to, that is first element of the matrix is alpha 0, because alpha k, here k value is 0, cos pi, let us see, 2n plus 1 by 2n into k. You see, 2n plus 1, as n equal to 0, 2 into 0 plus 1 into k is also here 0, divided by 2n, 2 capital N. So 2 capital N is 2. So 1 by root 2 cos 0, which is 1, equal to 1 by 2. So it is not written there. You may write in your copy because it is, I think some data is lost here. Isn't it?
Yes, sir. वो screenshot लेने में वो चला गया है.
हाँ ऐसा कॉलम में. So that is here 1 by root 2 cos 0 equal to 1 by root 2. Cos 0 is 1.
Cos 0 is 1, so it's 1 by root 2.
So 1 by root 2. We may write in your copy.
Yes, sir.
The answer of 2.1 is 1 by root 2. Okay.
फिर C01 निकालेंगे.
हाँ, C01 निकालेंगे, 1 0 निकालेंगे, 1 1 निकालेंगे. Okay, C01, k is equal to 0, n equal to 1. C01 equal to, you see, alpha 0 cos pi 2 into 1 as n equal to 1, 2n plus 1 into 0 by 2 plus 2. It is same as 1 by 2 cos 0.
ये इंटू जीरो सर, वो इंटू के कारण है क्या सर?
हाँ, इंटू के जीरो है ना।
फॉर्मूला में इंटू के है सर। एक बार
हाँ, इंटू
फॉर्मूला
के
दिखाइए।
हाँ, देखो
एक बार
देखो
फॉर्मूला दिखाइए।
देखो देखो।
ओके। ओके।
ओके,
ठीक है सर।
यू सी हियर।
ये स्मॉल एन और कैपिटल एन अलग अलग है सर?
अलग है।
ओके।
कैपिटल एन जो ऑर्डर ऑफ मैट्रिक्स है,
और
हमको दिया
स्मॉल एन
गया
क्या?
ना। ऑर्डर ऑफ मैट्रिक्स, यू सी।
स्मॉल एन क्या है सर?
यू सी, ए नहीं तो रो इंडेक्स लिखा
ओके
हुआ है नीचे,
ओके
देखो। हाँ,
ओके, थैंक यू
स्मॉल
सर।
कैपिटल एन इन द ऑर्डर ऑफ द मैट्रिक्स, here is 2, and small in the row index 0 to 1, either 0 होगा और 1 होगा।
तो के जीरो के लिए तो ये पूरा कॉस जीरो ही हो गया सर, जैसे ही
हाँ
मल्टीप्लीकेशन जीरो
हाँ,
से
दोनों
हुआ।
फास्ट दोनों 0 हो गया। हाँ, यस
हाँ सर।
यस। तो
फर्स्ट और
वन का
सेकंड तो
आउटपुट है वन
सेम
बाई
आ
रूट
जाएगा।
टू यस यस, वन का आया 1/√2, सेकेंड का आया 1/√2, थर्ड का देखिए, where k is equal to 1, n equal to 0, k 1, n 0, so c 1 0, alpha 1, alpha 1 का वैल्यू 1 है हियर, alpha 1 cos pi by 2 plus 1 into 1 2/2, that is I think alpha 1 cos pi by 4, नहीं,
पाई बाई
alpha
फोर
1
मल्टीप्लाई
in,
हो गया, कितना हो गया
हाँ,
सर?
pi by 4 1/√2,
1/√2। यस
हाँ,
सर।
cos pi by 4 1/√2, so
यस
1
सर।
into 1/√2, it is 1/√2, isn't it? So third one also
एक्सलेंट,
1/√2.
बहुत बढ़िया।
First one is 1/√2, second by is 1/√2, and third one is also 1/√2. Come to the last one,
सर
C11. Here k is 1 as well as n is 1. Alpha 1 into cos
पाई
pi
बाई
2
टू हो जाएगा।
1 1 1 2/4. That is I think
पाई बाई टू
5
हो
plus
जाएगा।
2 3 pi by 4.
3/4 pi,
हाँ,
3/4
3 pi
pi.
by 4. हाँ, yes yes. Cos 3
थ्री
pi
पाई
by
बाई
4, which is minus pi by 2, which is minus 1/√2. Because each pi by 4 is 1/√2, 3 by 4 is minus pi by 2.
सी
Okay,
वन वन माइनस 1/√2 हो गया है।
minus 1/√2. So you please write in your copy. That is, first one is 1/√2, second is 1/√2, third is 1/√2, but fourth one is minus 1/√2 because it is cos 3 pi by 4. Okay, so we find this value. But this is the answer. So a matrix can be represented with a common scaling factor 1/√2 taken common, 1 1 1 minus 1, and it is called orthogonal. Always the DCT is orthogonal. Why orthogonal? Because the inverse of the matrix is its transpose, equal to its transpose. You would take the inverse of this matrix, it is exactly same as it is transpose. So that is why DCT is always known as a orthogonal matrix. Sorry, orthonormal matrix. Uh, are you getting?
यस सर, इट्स फाइन।
सर ऑर्थोगोनल एक बार फिर से बता दीजिए।
That is the inverse of matrix is equal to the
ट्रांसपोज। हेलो सो आई कैन नॉट हियर यू। इज सर ऑडिबल?
ये पिक्सेल का बता रहे हैं ना सर, 2030 का, 230 का?
ऑर्थोगोनल मैट्रिक्स बता रहे
नहीं
हैं।
नहीं, मतलब MCS 230 का बता रहे
हाँ
हैं
हाँ,
ना,
हाँ, उसका
230 का बता
न्यूमेरिकल
रहे,
बता रहे
230
हैं,
का
उसका न्यूमेरिकल।
न्यूमेरिकल।
न्यूमेरिकल्स।
तो सब इम्पोर्टेंट न्यूमेरिकल्स ले रहे हैं ना सर?
हाँ, ये
हाँ, ये लास्ट ईयर आया हुआ है
आरसीपी
कुछ कुछ
क्वेश्चंस।
वैसे तो चलिए।
ओके ओके। तो फिर भी क्या क्या वेटेज होता है न्यूमेरिकल्स में?
नहीं, वेरिड है। मैंने सारा कंपाइल करके देखा है, पर वेरिड है। कभी कभी दिए हैं ज्यादा, कभी कम दिए हैं, एक ही दिया है, ऐसा है।
पूरे क्वेश्चंस कंपाइल किए हैं क्या पूनम आपने?
हाँ सर, मैंने दोनों के कर रखे हैं। एक शीट
एक बार
बना,
भेज देना
मैंने
ग्रुप
सर को
में।
230 की तो शेयर की थी,
एक बार
231
ग्रुप में
को
भी डाल देना पूनम प्लीज।
ग्रुप पे
एक बार
डालू
देख।
क्या?
हाँ, एक
हाँ,
बार डाल देना ग्रुप में प्लीज
ठीक है, मैं डालती हूँ ग्रुप पे।
मैंने तो
अच्छा
लास्ट ईयर का क्वेश्चन पेपर
इज
सेव
इट
कर
विजिबल?
यस।
नो सर, इट्स नॉट विजिबल।
1 मिनट,
इट्स नॉट सर।
क्या हो गया फिर?
आप कंपानियन मोड में चले गए सर दूसरे वाले उस पे।
नाउ इट इज विजिबल
इट्स
सर।
फाइन सर नाउ।
Okay. Achha, another transform, I have seen that there are some questions from hard transform. Explain hard transform with suitable example. Compute the discrete hard transform of a 2 cross 2 matrix. Uh, 2 cross 2 matrix. There, suppose a cross sign is not there, it is missing. 2 cross 2 matrix giving n equal to 2. Giving n equal to 2, we have explained it hard transform. Okay, so there are, you know that it is a discrete wavelength transform that decomposes the image into different subbands, and these are the theoretical. You see, for a 2 cross 2 matrix n equal to, the discrete Hart transform uses the simplest Hart matrix, even normalized to the orthonormal, as you discussed previous one. The normalized 2 cross 2 matrix S2 is 1 by root 2, 1, 1, 1 minus 1. And we know that the same is orthogonal matrix in this sheet 2 I have already discussed. And it is the same as a normalized 2 cross 2 matrix Hart matrix. The same matrix is known as a normalized 2 cross 2 Hart matrix. The 2D Hart transform of an input matrix X is computed as y equal to H2 into X H2X H2 transpose. As H2 transpose as is orthonormal, so H2 uh, transpose equal to H2 here because it is orthonormal, so transpose equal to it. So let us see an example. You will get this type of question. You see, let us compute the Hart transform of the generic 2 cross matrix input X and X equal to ABCD. Any number may be given in place of ABCD. Okay. Now wait 1 minute. I will discuss about this. Yeah.
हाँ,
Yes.
No, sir's voice is not coming.
Yeah, sir.
नहीं नहीं सर
Welcome.
अभी ब्रेक लिए हैं। सर वेट करने बोले।
ओके। लास्ट ईयर के क्वेश्चन पेपर किसने रिफर किए अभी तक?
मैंने
किए क्या?
अभी just questions देखे हैं. I'll start solving it.
मतलब मोबाइल कंप्यूटिंग के बारे में बोल रहे हो ना?
हाँ जी, 230 and 231.
ओके। और फिर मतलब क्या लगता है आपको कैसे ये होगा शॉर्ट्स में?
231 में कोई भी क्वेश्चन रिपीट नहीं हुए।
हुए ना, जीपीआरएस वगैरह हुआ है, एड हॉक
बहुत रेयर है, बहुत कम है, परसेंटेज कम है रिपीटेशन का।
हाँ। इसीलिए ज्यादा टेंशन आ रहा है।
पहले तो 31 है ना एग्जाम, 231।
यस सर, फर्स्ट इज 231,
नहीं, वेडनेसडे को।
थर्ड को, हाँ वेडनेसडे।
तो 2-3 दिनों में हो जाएगा क्या पढ़ाई?
टाइम नहीं है बाकी, और कब पढ़े।
पास करने लायक तो हो जाना चाहिए।
हाँ, होप सो।
वैसे भी 230 थ्योरेटिकल पेपर है।
हाँ 231 इज कंप्लीटली थ्योरेटिकल।
हाँ
संजय तो
तो
पूरा
रट्टा
तैयारी
मार के
करके
हो
बैठा
सकता
हुआ है कि ले लो एग्जाम।
है।
संजय का तो पूरा तैयारी हो रखा है कि ले लो एग्जाम, जल्दी से खत्म करो।
सर का न्यूमेरिकल देख रहे हो पहले?
वैसे तो थ्योरी थोड़ा बहुत हो जाता है, पर न्यूमेरिकल्स का बहुत ज्यादा प्रेशर आ रहा है, एक्सेल का। ऐसे किसी ने शॉर्ट में नोट्स नहीं निकाले क्या?
नहीं मैंने तो कुछ नहीं किया है,
हाँ,
अब
इस बार आया
देखूंगी।
नहीं, लोग दे देते थे ग्रुप में, इस बार किसी ने नहीं किया।
नहीं, आज एंड क्लास होने तो
हाँ
फिर
सर,
डालते
वो
हैं।
एक दिन पहले आते हैं हमेशा,
इम्पोर्टेंट क्वेश्चंस है।
एक दिन पहले आएंगे शॉर्ट नोट्स।
वो ना थोड़ा रिवाइज भी किया तो भी हो जाता है फिर, फटाफट फटाफट एकदम शॉर्ट्स में, क्योंकि क्लाउड कंप्यूटिंग का वगैरह आया था ना, तो अच्छे मतलब ये हो गया था, फायदा होता है उससे। क्योंकि ये पीपीटी भी देखा जाए तो मतलब 300 पेजेस तक जा रहे हैं, नियर अबाउट 250 to 41।
सर से बोलेंगे आज ना कि इम्पोर्टेंट टॉपिक कुछ सर इसमें सजेस्ट कर दो
हाँ, वही तो।
बिकॉज पीपीटी जो है बहुत पेजेस है, और इसको पूरा
वास्ट
एक
बहुत है
करके
ना।
नोट्स बनाने वेरी डिफिकल्ट। सर को इम्पोर्टेंट टॉपिक बोलेंगे सर, प्लीज सजेस्ट करें।
सर को ही बोलेंगे कि सर आप इम्पोर्टेंट टॉपिक्स के ऊपर थोड़ा थोड़ा एक एक बार रिवाइज कर देना, कौन से इम्पोर्टेंट है।
ऐसे रखना कि जो सूखा कपड़ा गीला ना हो, है ना।
टू 231 का पूनम आपने कब भेजा था?
हेलो।
231 आपने भेजा है ना? मैं ढूंढ रहा हूँ, ग्रुप में मिल नहीं रहा।
नहीं मैं अभी भेजती हूँ सर, मैंने भेजा
ओके
नहीं
ओके
है। I'll
ओके,
send, wait।
ठीक।
क्या 231 के क्वेश्चंस?
प्रीवियस ईयर्स 230 का तो किसी ने डाला हुआ है, लास्ट 5।
हाँ, मैंने शेयर किए थे ग्रुप में।
ओके, या किट्टू के नाम से है वो, दैट इज द।
हमारा ग्रुप कौन सा है? इग्नू एमसीए Jan 24 ना, ऑफिशियल वाला?
हाँ वही।
वही है ना? इतने सारे ग्रुप है, कुछ पता ही नहीं चल रहा है।
एमसीए वाला जो ग्रुप है ना, वो हम लोग का है।
अच्छा अच्छा,
ऑनलाइन सपोर्ट वाला।
हाँ ऑनलाइन
ऑनलाइन सपोर्ट वाला।
एमसीए ऑनलाइन सपोर्ट।
अरे वो कहाँ गया? एमसीए ऑनलाइन सपोर्ट तो दिख ही नहीं रहा। I got it. मैंने ना वो ये नहीं उसमें लिख रखा है कौन से ईयर वाला है, ओह सॉरी कौन से मंथ वाला है, मंथ
नहीं,
एंड ईयर नहीं डाला
कंपाइलेशन एक
था।
होता है ना कि जैसे एक टॉपिक से इतने क्वेश्चन से आ गए, उस तरह से भी
नहीं
मतलब जैसे
मैंने
भी बनाए
सारे
वो कर लो।
कंपाइल कॉपी पेस्ट कर दिए हैं।
हाँ, जैसे भी किया है वो कर दो, वो कर दो।
जो रिपीटेड थे वो क्वेश्चन नहीं डाले थे मैंने,
गॉट इट, गॉट इट।
है ना, मैंने कंपाइल करके कर दिया। सिक्सटी वन टोटल क्वेश्चन है।
थैंक यू मिस पूनम, थैंक यू
बिल्कुल।
सो मच। एक्चुअली इसको अगर चैट जीपीटी पे डाल देंगे इजी एंड शॉर्ट तो
हाँ
हाँ,
राइट, वो
तो
पूरा,
कीवर्ड्स मिल जाते हैं हमको फिर।
बस वही एक इशू है कि इसमें बहुत कम रिपीटेड क्वेश्चन है, तो वो एक प्रॉब्लम
ठीक है डिस्कस करेंगे।
पर मुझे नहीं लगता कि 61 में से मतलब पासिंग भी नहीं होगा, हो जाएगा मुझे लगता है कि।
हो जाए तो अच्छा
हो
है।
जाएगा, घुमा फिरा करके क्वेश्चंस होते हैं कभी कभी ना, वो हो जाते हैं। जैसे अब iOS XML का
हाँ बस
फीचर्स
अब
दोनों
लास्ट है तो जल्दी हो जाए खत्म सब सही से।
तो
हाँ,
मिस
बहुत
पूनम
ठीक है,
आपने
ठीक है,
जून
स्टार्ट करेंगे।
25 का भी क्वेश्चन
यस
पेपर
यस
दिया है
सर।
क्या?
देखिए एक क्वेश्चन आ सकता है, let us compute a hard transform of generic 2 cross 2 matrix, and any question can be asked s equal to a b c d, any number from for a b c d.
सर हार हार ट्रांसफॉर्म का मतलब क्या है सर?
It is also like your Fourier transform. Hard transform is another transform. So I got a question from hard transform yesterday. देखा तो मैंने ये क्वेश्चन डिस्कस करने के लिए सोचा।
सर कैन यू शो द स्क्रीन?
It is not seen.
स्क्रीन इज विजिबल।
It is visible.
यस सर।
यस सर, यस सर, थैंक यू।
Okay. You see here, compute a discrete Hart transform matrix 2 cross 2 matrix, and you know that for a 2 cross 2 matrix, the discrete Hart transform involves applying the 1D transform first to the rows and then to the column, and the input matrix is m equal to any matrix can be given m11 m1112 or 2122 form, but the normalized 2 cross Hart matrix H, which is the same as your orthonormal matrix of DCT2, we have already just discussed 1 by root 2 1 1 1 minus 1, and the same matrix is known as the normalized Haar matrix, which is denoted here H. So the 2D Haar transform is computed by T equal to H into M into HT. Okay. What is T? T is the transpose of H. So since H is symmetric, we know that in case of a symmetric matrix, S transpose A transpose equal to A. That is, a matrix is said to be symmetric if it is equal to its transpose. Isn't it? Skew symmetric matrix also there. If a matrix is said to be skew symmetric, if it is a transpose is equal to minus A. Suppose A T equal to minus A. But if A T equal to A, so it is called a symmetric matrix. And HT equal to H. So we need not to find out the HT because H itself is HT. Let us say an example. Let us use the specific example. We have taken M equal to जो ABCD में था, जो M11 M12 में था, तो 6 to then what are that 4 8. Okay, you see here. So first I have to apply the Hart transform to the rows, multiplies by M by HT, or which is H. That is, you may write MH or MHT because HT equal to H here. So rho transform equal to MH. So 6 to 4H 1 by root 2, and you know that H equal to 1 by root 2, 1, 1, 1 minus 1. You have to remember this matrix. And then 1 by root 2 taking outside or common. And this is a normal matrix multiplication. 6 into 1 plus 2 into 1. Then 6 into 1 plus 2 into minus 1. Then 4 into 1. Then second row, first column of the second. 4 into 1. Please recall the matrix multiplication method. And finally we get 1 by root 2, 8, 4, 12 minus 4. So once we find MR or M row transform, so then we multiply with H, because our formula is HMHT. HMHT. So first we find HM or HMT, then multiplied with H. You see HM. So M is nothing but M is MH or MHT. So 1 by root 2, 1 into 1, H is here. Again, the final matrix, which is 1 by root 2, 8, 12, 4 minus 4. 4 minus 4, I think it is not written there, but you write 4 minus 4. 1 by root 2, 1 into H into what is your M row transfer is, we have just calculated 1 by root 2, 8, 4, 12 minus 4. And this is so again 1 by root 2 into 1 by root 2 is 1 by 2, and 20, 8 into 8, 12, 20, 0 minus 4, 8. And if 1 by 2 is multiplied in each element of the matrix, we will get 10, 0 minus 2, 0 at the final result. Okay, or any issue?
इससे पहले वाली स्लाइड पे जाइए सर प्लीज. So can you go back one slide? Okay, sir. Now next, sir.
Okay, so here
Next slide. Next
y is
slide.
equal to htx. We have taken m there, but h2 into x. So you have to remember this. Actually, it is not difficult. The numerical is not difficult. So, but you have to remember these terms or these formulae. The hard 2D transform is equal to h2 x h2 dash or transpose, and the normalized 2 cross is 1 by root 2 1 1 1 minus 1. Okay. So it is not given in the question. You have to remember this. Achha, another important question from city. It is not in your PPT. It is my handwritten. मिनट कहाँ गया? मैं बंद करता हूँ और ओपन करता हूँ.
Sir,
Hmm.
sir,
Yes, Blue.
sir, can you tell some important questions from the MCS 231?
Actually, 231 is not difficult. 231 is it is given. You see the previous question. You see the previous question. All
Yes.
the IP is important. Your types of networking, type of your MC technology. All the technology are 5G, 4G, Bluetooth technology. your Zigbee मैंने भी देखा Zigbee बहुत बार आया. Okay, or your all the technologies. That is your IPv6, IP6, mobile, your internet protocol, mobile database. You see the previous question, and there are no numerical, only theoretical question are there and not difficult at all. So is it visible?
Yes, sir.
Yes, sir.
Not clearly, but it is readable, na? You see
Sir,
here.
it's fine, sir.
Yes, it is visible.
Acha. You see here, sometimes you get from DFT, that is one dimensional DFT and inverse DFT. The formula of one dimensional DFT is, it is a numeric, that is fk equal to summation of x equal to 0 to n minus 1. What is capital N? Order of the matrix. F of x e to power j2 pi kx by n. What is j? Now j equal to imaginary number. You recall the I, imaginary, I square equal to minus 1.
Yes, sir.
Okay, here I have taken j. So same it is j square equal to minus 1. So you take that the imaginary number complex in a, you have used in the complex number a plus I b, that I. So it is j. Do not confuse, that same j is here. And you will get fk from fx. Fx is your spatial form. As we discussing one
Your voice is cracking, sir.
day, 1D, so we will give the value as f of x, not f of x. So we have called f of, is it audible now? Hello?
Yes, sir.
Okay. You see here. That is, I am converting I want to converting f of x, which is given in spatial form, to the frequency from capital F of k. Using this formula. That is, as it is a discrete Fourier transform, we want to transform from fx to f of k using this formula. And again, after converting I make some modification. I want to again convert that f of k to f of x originally, which was originally f of x, using inverse DFT. This is the formula. Well, f of x equal to 1 by n summation of k equal to 0 to n minus 1 f of k e to power j 2 pi kx by n, and where x equal to 0 to n minus 1. This is the formula. This formula actually looks complex, but actually it is easy when to compute. When we will compute, you will find that it is not difficult. It looks like it is a complex equation. Okay. So based upon these two questions, you will get a question. Compute DFT of the sequence f of x 1001. Sometimes it gives matrix form 1001. Do not confuse. So we have a spatial form 1010. We have to convert this to which form? Frequency form, frequency domain. You see now what is n here? The number of
And it's
elements.
4.
4. The number of element 4. And you assume that the first number is 0, the index of first number 1 is 0, then 1, then 2, then 3, like an array. Your array in any programming language, as you know, the index start from 0, not 1. So here
Yes.
also you see the element of f of x 1 0 0 1. You assume that their index is 0 1 2 3, that is 0 to n minus 1. So as here is n minus 4, f of k is equal to, you see the formula, s to power 0 to 3, because you given that the summation of s equal to 0 to n minus 1, n minus 1 of 3, f of x e to power minus j 2 pi kx by n, where k is equal to 0 to 3. You see, then how to, you see here. So summation खोल दीजिए, f of 0, x value 0, on e to power 0 means x is there, so 0 into something equal to 0, e to power 0. The second one, f of 1, f of 1, then e to power j 2 pi k by 4, because n is 4 here, plus f of 2, e to power minus j pi k, because 2 become 2 4, 4 4 should be cancelled, and minus j pi k, and f of 3, so x is 3 here, so f3 into e to power j, x is 3 pi k by 2, because it becomes 6 by 4 is equal to 3 by 2. Is it okay? No, any problem?
yes sir. ये थर्ड वाला 0 कैसे हो गया सर?
थर्ड वाला,
हाँ, वन,
कौन सा?
फर्स्ट टर्म इज 1 इज फाइन, e to the power 0 इज 1, सेकंड इज 0 इट्स फाइन बिकॉज यहाँ पे 0 था x.
हाँ, थर्ड वन इज 0 समथिंग ना, f2 0 ना.
ओके, f2 इज 0. यस सर, यस सर.
हाँ, f2 0 क्वेश्चन में है ना, 1 0 0 1.
यस सर.
So f2 0, so 0 into something 0, and third one is f3 is 1, so 1 into that term, e j 3 pi k by 2. So that is 1 plus e to power minus j 3 pi k by 2. ठीक है? Then
सर
we are
ये
putting,
भेज दोगे क्या आप ग्रुप पे?
sorry,
ये न्यूमेरिकल जो आप सॉल्व करवा रहे हो वो आज भेज दोगे क्या ग्रुप पे प्लीज?
हाँ कर दूंगा. ठीक है,
ओके
देखिए.
सर.
So when k is equal to 0, f0 is equal to 1 plus e0, is it 2, e0 is equal to 1, and when k is equal to 1, f1 equal to e plus माइनस जे. अच्छा, एक देखिए, ये जो मैंने लिया 1 प्लस जे, हाउ जे, देयर इज ए स्टैंडर्ड फॉर्मूला, यू सी, व्हाट इज द स्टैंडर्ड फॉर्म, दिस वन, यू सी, वी नो दैट e to power I pi, I is imaginary number, I have taken j here, so do not confuse, they are same as I, e to power ij or I pi equal to minus 1. This is standard formula mathematics. This is I am not written in myself. You may find it from the internet or any formula for this. E of I pi equal to minus 1, e of minus I pi equal to minus 1, e of I pi by 2 equal to I have written j here in place of I, so you can write j here. E of minus j pi by 2 minus j, e of minus z 2 pi is equal to 1, e of minus z 3 pi is equal to minus 1, e of minus z 3 by 2 j, और e of minus z 9 by pi 2 minus j. नीचे जो दो फॉर्मूला है अभी जरूरत नहीं है. e minus j theta, e j theta, ये फॉर्मूला we know that this is e minus I theta और e minus this is the formula we know, पर ये रिक्वायर नहीं है अभी. देखिए 1 minus 1 j minus j 1 minus 1 j minus j. Okay, so I have used this formula in that numerical. Okay, you see here, when k is equal to 1, f1 equal to 1 plus e 3j pi by 2, which is equal to j in previous slide. Sorry, in that formula. Similarly, where k is equal to 2, f2 equal to 1 plus e minus j 3 pi. That is the value of it is minus 1. So 1 minus 1, it becomes 0. And when k is equal to 3, you put the formula there, 1 plus e to power j 3 into pi into 3, 9. That e to power minus j 9 pi by 2 is 1 minus j. Because e j 9 pi by 2 is minus 1. It is, you see, it is written in this, you see the last part. E minus j 9 pi by 2 is equal to minus j. Okay. So fk finally 2 I plus I or I plus j 0 I minus j. So this is the Fourier transform of f of x. Are you getting or any problem?
No, sir. Only this formula is there. We will have to
Some
work it out.
formula there you have to remember.
Yes, sir.
Otherwise,
Yes.
I don't think it is difficult.
No, sir. Finding it is not difficult.
It looks like when you see that it looks like the complex formula there, complex equation are there, but actually it is not difficult. F0 is given in the question, F1 is given in the question, and e to power all the things are given in the formula. Value of e to power something, it is given in the formula. So you put that formula and get that formula. So this is your discrete transform. 2 1 plus j 0 1 minus j. This is the final answer. Okay, so do not confuse, as I tell, j equal nothing but is I, imaginary number, whose I square equal to minus 1 or root over minus 1 equal to I. Then come to this part. Achha. Sometimes you will get a 2 DFT. 2D is 1D, which the last question is 1D. But sometimes you get the 2D. So it is difficult to calculate 2D because 2D contains two summation part. Please see our slides. In DFD we have discussed two for 2D there are two summation part which are difficult. So you use instead using the kernel DFT. Okay, a kernel of a 4-point DFT is given you see here. You have to remember this kernel. How to remember you see? Kernel of a 4-point DFT is 1 1 1 1. You see the first row, first column. First row, first column is all 1 1 1. You write first them. Then start from minus j. Okay, minus j. Then write minus 1 plus j minus 1 plus j. Then minus 1 come down. Then minus 1 minus 1. Then j minus 1. Alternatively. Are you getting or not? It is a formula to remember only. First write 1 1 1 1 1 1 1 1 in rows and column. Then start from minus j minus 1. Then j minus 1. You see small j. Then minus 1 niche. Then minus j minus 1. Then j minus 1 alternatively. After writing, write 1 in middle. So it is easy to remember. Are you getting my point or not? How to
Yes, sir.
remember?
Yes.
How to remember the comment? You have to only write that formula only. ओके
वन 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 सारे में लिख लिए, रो में कॉलम में, देन वी स्टार्ट विथ माइनस जे
माइनस जेन माइनस वन
एंड
जे
देन
माइनस
अल्टरनेट।
वन ऑल्टरनेटिवली एंड मिडिल में वन।
यस
जो
सर,
बाकी
यस
रह
यस।
गया एक एक मिडिल में एक एलिमेंट बाकी रह गया उसको बस वन लिख दीजिए।
ओके।
ठीक है। So 1D DFT already discussed. So no need to multiply with the kernel into fx. But if you find with kernel not using that formula, you just write fk is equal to kernel into f of x. Simply multiplication कर दीजिए, you will get your answer. But for 2D DFT, this is important. FKL, that is f of xy. You can write I am taken KL, but you write f of capital X capital Y. Kernel into f of xy into kernel transpose. कर्नल इंटू एफ ऑफ एक्स वाई इंटू कर्नल ट्रांसपोज। ठीक। सो 2D DFT में जो फॉर्मूला यूज करके हम करेंगे तो थोड़ा कॉम्प्लेक्स होगा, बिकॉज इसमें टू समेशन है, एक इनसाइड समेशन अनदर दैट इज योर लाइक योर आउटर लूप इनर लूप, सो दैट इज इट विल बी डिफिकल्ट, सो यूज कर्नल इंस्टेड। ओके, यू सी हियर आई हैव a important question here. Calculate a 4-point DFT for the sequence of fx 0, 1, 2, 3 using matrix method. So the 4-point DFT is one dimensional is kernel into input sequence. So simple multiplication कर दिए, as is 1D, you will get the answer. Kernel into f of x only, बस. It is for 1D only.
ये तो सिंपल मल्टीप्लिकेशन
हाँ,
मैट्रिक्स
ये
का हो गया
सिंपल
सर।
मल्टीप्लिकेशन हो गया। बट 2D में देखिए, compute
ओह
the
माय
2D
गॉड।
DFT, हाँ, compute the 2D DFT of the grayscale image is given by f of xy. 1, 1,
ये
1,
बहुत
1, 1, 1.
डिफिकल्ट।
Yes, yes. So fkl is equal to kernel into fx fy into kernel t. Kernel you know. See here. Kernel 1, 1, 1, 1 into fxy is given the question. Then it's gonna transpose. You'll get the same kernel because kernel t equal to kernel. So simply multiply the first two. You will get 4, 4, 4. The next place is 0. Then multiply with kernel transpose. So we will get 16 and all the other element is 0. So this is your FKL using kernel matrix for DFT, 2D DFT. So it is not difficult, but it takes time for multiplication of a 4x4 matrix. Okay, are you getting?
इट्स फाइन सर।
Okay. So this is all about. So please wait 1 minute. I will take the. So please write your name and enrollment number.
स्टार्ट में ही लिख दिया था सर, दोबारा लिखूं?
लिख दिया था? नहीं नहीं नहीं, दोबारा नहीं।
सर स्टार्टिंग में हमने लिखा था 9
ठीक
बजे
है, कोई बात
15 मिनट
नहीं।
पे।
हाँ ठीक है, ठीक। ओके,
सर
सो
ये सेंड कर देना ना
हाँ सेंड कर
न्यूमेरिक।
दूंगा, आज सेंड कर दूंगा। और बाकी कुछ और कुछ प्रॉब्लम है, यू मे कॉल मी, आई हैव अ नंबर इन योर ग्रुप, so you may call me and or any issues, any problem comes, so you may contact me.
यस
And
सर, मोस्टली
okay,
श्योर सर,
एमसीएस
okay,
थैंक यू।
thank you,
का ही
all
आपको
the
थोड़ा
best,
सा,
थैंक यू सर,
all the
थैंक यू
best
सर,
for
एग्जाम हो
थैंक यू
exam.
जाएगा
सो
तो
मच
मैं
सर,
भेजता
थैंक
हूँ।
यू।
एमसीएस टू थर्टी का ही थोड़ा
Okay,
सा है
let us
आपका।
leave.
Thank you, sir.
थैंक
Thank
यू।
you, sir. Thank you, sir.
थैंक यू सर।
थैंक यू सर।
अब तो हमारी क्लास 3 बजे से है, फिर 1 बजे से है ना सेकंड क्लास?
1 बजे से, 1 बजे से।
1 से।
क्या वो
ठीक है,
सर फिर से डिस्कस ही करेंगे, क्या करेंगे, कुछ बताएंगे?
वैसे ही डिस्कस ही करेंगे। दिस इज मोर अबाउट दोज हु आर नॉट रेडी विद द प्रोजेक्ट।
अच्छा, यानी जिन्होंने सबमिट
उन
कर
लोगों
दिया
के
उनके
लिए
लिए
ज्यादा
नहीं है?
इम्पोर्टेंट। हाँ हाँ, जो सबमिट कर दिया है आई थिंक उनका वाला ज्यादा वो इफेक्टिव नहीं है, लेकिन जिसका नहीं हुआ है ना उन लोगों के लिए ठीक है। वैसे भी
लेकिन
क्लास लेते कहाँ है, बस डिस्कस करके ओवर कर देते हैं।
पिछले बार भी तो 15-20 मिनट में खत्म कर दिए थे सर।
हाँ ठीक है,
कोई
फिर
बात।
1 बजे कनेक्ट करते हैं। ओके।
चलो, ओके ओके, बाय।
बाय।